In this lesson, I'm going to begin by talking about perimeter and area. To illustrate the meanings of these terms, I've got a rectangular prism here, but I want to consider just this face of it. If I want to talk about the perimeter of this rectangle, then I want to talk about the distance around the outside. Each of the squares that you see here has a length of 1 inch and a width of 1 inch. That means that I can say that if I were an ant and wanted to crawl around the outside of this rectangle, then I would have to travel 3 inches, then another 4 inches, then 3 more inches, and then 4 more inches, for a total of 14 inches. That means that I can say that the perimeter of this rectangle is equal to 14 inches. The area of a two-dimensional figure refers to the amount of space contained inside the figure. In general, when we want to talk about the area of something, we usually use square units. Each side of the figure that I have here has a length of 1 foot, and the shape is a square. That means that I can say that this shape has an area of 1 square foot. If I say that something has an area of, for instance, 23 square feet, then I am saying that the amount of space inside the figure is equal to the total amount of space that you would have inside 23 squares that are identical to this one. Now let's go back to this face of my rectangular prism. As I said earlier, the length of each of these sides is 1 inch, and the shape that you see here is a square. That means that this shape represents 1 square inch of area. If you want to talk about the area of this rectangle, you can count the number of squares I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The area of this rectangle is 12 square inches. Or you can use the formula area of a rectangle equals length times width. For a rectangle, it doesn't really matter which dimension I call the length and which dimension I call the width. After all, if I turn my rectangle like this, my length just became my width, and my width just became my length. To use this formula to talk about the area of my rectangle, you can multiply 3 inches times 4 inches. 3 times 4 is 12, and inches times inches gives you square inches. Now let's look at the example you see here. Let's suppose that the light horizontal and vertical lines are all 1 centimeter apart. I'm going to find the area of the outlined figure. I'll start by talking about the full squares. Since the light horizontal and vertical lines are all 1 centimeter apart, I can say that each of these full squares represents 1 square centimeter of area. Now let's look at the partial squares. I can take the triangle you see in red here and move it to where you see the gray triangle. And now I can change the boundary of my shape so that it goes with the purple segments that you see here instead of the original black segments. Note that when I do this, the area, or the amount of space inside my shape, has not changed. This gives me an additional 1 square centimeter of area. I can repeat this process with the other red and gray triangles you see here. If I move the area in the red triangle to the area in the gray triangle, and then change my boundaries to match the purple segments instead of the original black segments, the area of my original figure has not changed, but now I can say that I have an additional 2 square centimeters of area. And now I can repeat the process one more time with these 2 triangles. If you count up the number of full squares that I now have labeled, you should get 17. Since each one represents 1 square centimeter of area, I can now say that the area of this shape must equal 17 square centimeters. In the next portion of this video, I'm going to talk about how you can use the formulas you see here. I'll start by talking about circles. When we talk about the distance around the outside of a circle, we usually don't call it the circle's perimeter because the circle does not have sides. Instead, we usually talk about the circle's circumference. To find the circumference of a circle, you can multiply 2 times the number pi times the radius of the circle. In the past, you have probably used the approximations of 3.14 or 22/7 for pi. However, pi is actually an irrational number, and that means that it never stops and never repeats and is therefore only approximately equal to 3.14 and 22/7. So, if we want to find the exact circumference and area of a circle, we must write these in terms of pi. On the other hand, if the problem you're working is a word problem, the problem is probably going to want you to use the pi button on your calculator and get a decimal approximation for the answer to the question. In this example, the length of the radius of the circle, or, in other words, the distance halfway across the circle, is equal to 10 feet. Multiplying 2 pi times 10 is a lot like multiplying 2x times 10. Since 2x times 10 is equal to 20x, I can say that 2 pi times 10 is equal to 20 pi. As far as my units, the feet in this part of the problem are not getting multiplied by another unit, so my units for this part of the problem will be feet. This tells me that the circumference of the circle is equal to 20 pi feet. To find the area of a circle, I can multiply pi times the square of the radius of the circle. As I said earlier, the radius of the circle you see here is equal to 10 feet. Therefore, I can find the area of this circle by multiplying pi by the square of 10 feet. To simplify this, the order of operations says that I must start by squaring the 10 feet, or, in other words, by multiplying 10 feet by itself. To multiply 10 feet by itself, I'll note that 10 times 10 is equal to 100, and then I can multiply feet times feet by writing square feet. To continue simplifying this, I just need to multiply 100 times pi and then keep my units of square feet. Again, you may have used the decimal approximation of 3.14 for problems like this in the past, but you need to realize that this will give you an answer that is only approximately equal to the true area of the circle drawn here. For my next example, I'm going to find the perimeter and area of the square that you see here. Since the question tells me that this is a square, I can start by labeling the other sides as having lengths of 9 miles as well. As I said earlier, the perimeter of a figure is defined as the distance around the outside, and you can think about the total distance that you would have to travel if you were driving around the outside of the figure. This should tell you that the perimeter of this square is 36 miles. To find the area of this square, I can use the formula for the area of a rectangle. Many students don't understand that a square is also a rectangle, but the definition of a rectangle says that the figure has to have 4 sides with 4 right angles. Since I do, in fact, have that here, I can say that this figure is also a rectangle, and therefore I can multiply its length by its width to find its area. As I said in red, you can also say that you want to multiply the rectangle's base by its height if you want to find its area. If you think about the meanings of these terms, you should realize that you're saying exactly the same thing. Since the length and width of this rectangle are both 9 miles, I can substitute these measurements into the formula as you see here. To simplify this, I'll note that 9 times 9 is equal to 81, and that I can multiply miles times miles by writing square miles. To help you understand the meaning of this, I'll note that I can split this figure up into 9 rectangles that are all 1 mile wide, as you see here. And then I can split these rectangles into squares that are all 1 mile long. If you think about my model from earlier, this should tell you that the green square that you see here represents 1 square mile of area. And if you count up the number of squares here, you should find that you have 81 of them. Since each square represents 1 square mile of area, I can say that this rectangle must have an area of 81 square miles. Before I can work my next example, I need to discuss the Pythagorean theorem. The Pythagorean theorem says this: in a right triangle, if A and B represent the lengths of the sides that form the right angle, and if C represents the length of the hypotenuse, or, in other words, the side opposite the right angle, then A squared plus B squared is equal to C squared. Now let's look at how I can apply that to the triangle you see here. First of all, I'll note that the square in the left corner of this triangle tells me that that angle is a 90-degree angle. Since that means that this is a right triangle, I can use the Pythagorean theorem here. In this triangle, I know that the length of the hypotenuse, or the side opposite the 90-degree angle, is equal to 5 meters. That means that I'll substitute 5 meters for my C in the formula A squared plus B squared equals C squared. As far as my A and B, it doesn't matter which one is A and which one is B, they just have to be the two sides that form the 90-degree angle. I chose to substitute the 4 meters for A, but you could have chosen to substitute it for B instead. I want to find the length of the other side that forms the 90-degree angle, and that means that I'll leave B as a variable. For my next step, I'll square the 4 meters and the 5 meters. Since an exponent of 2 tells you that you want to multiply something by itself, I can square 4 meters by writing 4 meters times 4 meters. To simplify this, I'll note that 4 times 4 is equal to 16, and that I can multiply meters times meters by writing square meters. I can also follow a similar thought process to square the 5 meters. 5 times 5 is equal to 25, and I can multiply meters times meters by writing square meters. For my next step, I'll subtract 16 square meters from both sides of the equation. To see why I said that 25 square meters minus 16 square meters is equal to 9 square meters, you can think about changing the square meters to x's. Since 25x minus 16x is equal to 9x, I hope that you can see how this gives me the equation b squared equals 9 square meters. You might find it helpful to go back and watch the beginning of this video to understand why this rule works. Now let's think about what this equation means. The exponent of 2 on the b tells me that I multiplied something by itself to get 9 square meters. Since 3 meters times 3 meters is equal to 9 square meters, I can say that b must equal 3 meters. Now let's find the area and perimeter of this triangle. As I just found, the third side of this triangle must have a length of 3 meters. That means that I can say that the perimeter, or the total distance around the outside, of this triangle must equal 12 meters. To find the area of this triangle, I can use the formula area of a triangle is equal to 1/2 multiplied by its base times its height, where the base and height form a 90-degree angle. Since the 3 meters and 4 meters form a 90-degree angle, I can find the area of this triangle by multiplying 1/2 times 4 meters times 3 meters. Note that I cannot use the 5 meters as either the base or the height because it does not form a 90-degree angle with either of the other two measurements that I have. To simplify this, I'll note that 1/2 times 4 times 3 is equal to 6, and that meters times meters is equal to square meters. Therefore, the area of this triangle must equal 6 square meters. For my next example, I'm going to find the perimeter and area of the trapezoid that you see here. I can call this figure a trapezoid because it has 4 sides and only 2 of them are parallel to each other. I'll start by finding the perimeter. In order to find the perimeter, I have to know the length of the 4th side. To find that, I'll draw the gray dotted segment you see here. This gives me the blue rectangle that you see here. Since opposite sides of a rectangle are congruent, that means that I can label the other sides of this rectangle as having lengths of 6 centimeters and 11 centimeters. Since the question told me that the length of the entire bottom segment is 19 centimeters, that means that the remaining part of this segment must have a length of 8 centimeters. I can now use the Pythagorean theorem again. Since I want to know the length of the side of the triangle that is opposite the 90-degree angle, I will leave c as a variable for this problem. I chose to substitute 8 centimeters for A and 6 centimeters for B, but you could choose to substitute 6 centimeters for A and 8 centimeters for B if you wanted to. Since these are the two sides that form the 90-degree angle, you should be able to see that the lengths of these sides represent the values of A and B here. I can square 8 centimeters by multiplying 8 centimeters times 8 centimeters. And I can square 6 centimeters by multiplying 6 centimeters times 6 centimeters. This tells me that C squared must equal the sum of 64 square centimeters and 36 square centimeters. If you think about what 1 square centimeter of area represents, it should make sense to say that when I add 64 square centimeters of area to 36 square centimeters of area, I get 100 square centimeters of area. To find the value of C, I need to realize that the equation you see here tells me that I multiplied something by itself to get 100 square centimeters. Since I can multiply 10 centimeters by 10 centimeters to get 100 square centimeters, I can say that C must equal 10 centimeters. That means that I can say that the fourth side of my trapezoid must have a length of 10 centimeters. Now I can find the perimeter of this trapezoid by adding the lengths of all the sides together. When you do this, you should find that the perimeter of this trapezoid is equal to 46 centimeters. When they see a problem like this, many students also try to add the 6 centimeters a second time. However, since the definition of the perimeter of a figure says that this is the distance around the outside of the figure, you should realize that you want to add the lengths of all the sides that you see in purple together, but you don't want to add the 6 centimeters that you see in gray on the inside of the figure. To find the area of this figure, I can use the last formula you see in blue on the screen. The bases of a trapezoid are the two sides that are parallel to each other, and so I can say that the bases of this trapezoid have lengths of 11 centimeters and 19 centimeters. As I said in the note in the middle of the screen, the height must form 90-degree angles with the bases. Since the side that has a length of 6 centimeters forms a 90-degree angle with both the side that has a length of 11 centimeters and the side that has a length of 19 centimeters, I can say that the height of this trapezoid must equal 6 centimeters. That means that I can find the area of this trapezoid by performing the calculations that you see here. The parentheses tell me that I need to start by adding the 11 centimeters plus 19 centimeters. To see why this is 30 centimeters, let's look at the ruler. If I put 11 centimeters together with 19 centimeters, I should get 30 centimeters. To multiply 1/2 times 6 centimeters times 30 centimeters, I'll note that 1/2 times 6 times 30 is equal to 90, and that centimeters times centimeters is equal to square centimeters. Now let's look at another example. In this example, you can assume that all the angles you see here are 90-degree angles. Of course, the perimeter of this figure is equal to the distance around the outside of the figure, or, in other words, the answer you get when you add the lengths of all the sides of the figure together. However, the figure does not tell me what all those lengths are. That means that I'll split this figure up into two separate rectangles by drawing the dotted gray segment you see here. Since the lengths of the opposite sides of a rectangle are congruent, I can label the length of this segment as 9 meters. I can also use the fact that the opposite sides of a rectangle are congruent to say that the length of this segment must be 13 meters. Since the combined lengths of these segments is 22 meters, this tells me that the top side of this shape must have a length of 22 meters. To find the length of the remaining side, I'll start by drawing the gray dotted segment you see here. Since the opposite sides of the rectangle you see in blue must be congruent, I can say that the right side of the rectangle you see in blue must have a length of 7 meters. Since the entire right side of this figure must have a length of 19 meters, the remaining portion of this segment on the right must have a length of 12 meters. I can use the fact that the opposite sides of a rectangle must be congruent again to say that the left side of the rectangle you see in blue must have a length of 12 meters. I can now find the perimeter of the figure by adding the lengths of all the sides together. Again, recall that the perimeter of a figure is the distance around the outside of it, so I don't want to add any of the lengths of my dotted segments. To find the area of this figure, I'll split it up into the rectangles you see here. I could also split the figure into the 3 rectangles that I had earlier. If I had chosen to do this, I would have made more work for myself, but I would have gotten the same answer we're going to get shortly. I can find the area of the rectangle I've labeled rectangle A by multiplying 7 meters by 9 meters. Since 7 times 9 is 63, and since meters times meters is square meters, I can say that the area of the rectangle I've labeled rectangle A must equal 63 square meters. To find the area of the rectangle I've labeled rectangle B, I can multiply 13 meters times 19 meters. Since 13 times 19 is equal to 247, and since meters times meters is equal to square meters, I can say that the area of rectangle B must equal 247 square meters. Now I just need to put these areas together. If you think back to the examples I started this lesson with, you should see how it makes sense to say that if you put 63 square meters of area together with 247 square meters of area, then you will get 310 square meters of area. To talk about the area of the shaded region for the figure you see here, I'll start by talking about the area of the circle. Since the question tells me that the circle has a radius with a length of 10 centimeters, I can find the area of the circle by multiplying pi times the square of 10 centimeters. Since I can square 10 centimeters by multiplying 10 times 10, and noting that centimeters times centimeters is equal to square centimeters, I can now say that the area of the circle must equal 100 pi square centimeters. For my next step in this problem, I'll find the area of the trapezoid. To do this, I'll use the last formula you see in blue here again. As I said earlier, the bases of the trapezoid are the sides that are parallel to each other, and so I can say that the lengths of those sides will be 37 centimeters and 28 centimeters. To figure out the height, I'll note that this question told me that the circle has a radius of 10 centimeters. That means that I can say the diameter of the circle must be equal to 20 centimeters. Since this segment does form 90-degree angles with both of the bases, I can say that the height of my trapezoid must equal 20 centimeters. And therefore I can calculate the area of the trapezoid by performing the calculations you see here. To simplify this, I need to start by adding the 37 centimeters plus 28 centimeters. This is equal to 65 centimeters. And then I can multiply 1/2 times 20 centimeters times 65 centimeters. 1/2 times 20 times 65 is equal to 650, and centimeters times centimeters is equal to square centimeters. Now let's talk about what I just found. In the last step, I found the area of the entire trapezoid. So, to find the area of the shaded region, I'll start with the area of the trapezoid, and then I'll take away the area I don't want, which is the area of the circle. That means that I can write the answer to this question as you see here. Subtracting 650 minus 100 pi is a lot like subtracting 650 minus 100x. And since I cannot combine 650 with 100x by adding or subtracting because they are not like terms, that means that I cannot combine 650 and 100 pi by adding or subtracting either. For my next example, I'm going to suppose that I have a rectangular room that is 15 feet wide and 12 feet long, and that I want to put carpet that costs $10 per square yard in the room. To figure out the amount of money that it will cost me to do this, I'll start by drawing a picture of the room. Since the question talks about square yards, that should tell you that we want to talk about area. However, if I find the area of the rectangle as I have it drawn here, that will give me the answer in square feet. So, I'll convert these dimensions to yards. To do this, you need to recall that 1 yard is equivalent to 3 feet. Since there are 5 groups of 3 feet in 15 feet, I can say that 15 feet are equivalent to 5 yards. If you have trouble understanding why this is true, you may find it helpful to actually mark off 15 feet with a ruler, and then find the number of groups of 3 feet that you can make from this 15 feet. You can also use a process called dimensional analysis, and there is a video on that process in the Other Videos section of our website. I can use a similar thought process to say that there are 4 groups of 3 feet in 12 feet, and so 12 feet must be equivalent to 4 yards. I can now say that I can find the area of the room in square yards by multiplying 4 yards times 5 yards. Since 4 times 5 is 20, and since yards times yards is square yards, I can say that my room must have an area of 20 square yards. Now, note that the question tells me that each square yard of carpet will cost $10. To find the cost of the carpet, I can add $10 to itself 20 times, or, equivalently, multiply 20 times $10. I can now conclude that it will cost $200 to carpet this room. In my final set of examples for this lesson, I'm going to talk about the terms lateral area, total surface area, and volume. When I use these terms, I'm talking about 3-dimensional objects like the ones you see here. Note that this is a change from what I've been talking about because I only talked about 2-dimensional shapes in the first part of this lesson. Before I can discuss the terms lateral area, total surface area, and volume, I need to give you some more definitions. I can use the term prism to describe the objects that you see here. I can use that term because they all have 2 identical faces, which we call bases, and they all have sides that form 90-degree angles with these bases. These faces are called the lateral faces. We name prisms by describing the shapes of their bases. For instance, I can call this prism a rectangular prism because its base is a rectangle. The prism that you see here is an example of a triangular prism because it has 2 bases that are both triangles. That means that the lateral faces of this prism will be these rectangles. The prism that you see here is an example of a hexagonal prism because it has 2 bases that are both hexagons. That means that the lateral faces of this prism will be these rectangles. This is another example of an object that I can call a rectangular prism because I can call its base a rectangle. However, I can also call it a cube because all of its edges have equal lengths. This is an example of an object that we call a cylinder. When I talk about lateral area, total surface area, and volume in a moment, I'll group this with the prisms because the formulas that we use to calculate these quantities will be nearly identical to the ones that we use to calculate these quantities for the prisms. However, because the bases are circles and not polygons, I should technically not call this a prism. I can call the objects that you see here pyramids, and this is an example of a cone. Note that these objects are different from the prisms because they all meet in a single point at the top. This point is called the apex of the pyramid or cone. I'm not going to discuss pyramids or cones further in this video. And finally, this is an example of a sphere. Now let's talk about the meaning of the term lateral area. The lateral area of an object is equal to the total area of all the lateral faces. To illustrate the meaning of this term, I'm going to revisit the rectangular prism that I have here. I'm going to use this face as one of my bases because I've already shown you that the area of this base is equal to 12 square inches. However, because this is a rectangular prism, you should be able to see that I can use any 2 parallel faces as my bases. Since I'm going to use this face as a base, that means that the lateral faces will be the faces you see here. If you calculate the total area of these faces, you should find that you get a total area of 28 square inches. And so I can say that the lateral area of this rectangular prism is equal to 28 square inches. The total surface area of an object is defined to be equal to the total area of each of the outside surfaces. To talk about the total surface area of this prism, I just need to add the areas of each of the bases to the lateral area that I just found. As I said earlier, each of these faces has an area equal to 12 square inches. This tells me that the total surface area of this rectangular prism must equal 52 square inches. To find the volume of any prism, I just need to multiply the area of a base of the prism by the height of the prism. I'll use this face as my base again. As I said earlier, this face has an area equal to 12 square inches, and that means that I can find the volume of this prism by multiplying 12 square inches by 2 inches. To simplify this, I'll note that 12 times 2 is equal to 24, and I can multiply square inches by inches by multiplying inches times inches times inches. Since we often refer to something that is raised to the third power as the cube of something, that means that I can say that the volume of this rectangular prism will be equal to 24 cubic inches. To help you understand the meaning of this, let's take a look at this cube. The length of each side of this cube is 1 inch, and that means that I can say that this cube has a volume of 1 cubic inch. And if you count the number of cubes that I have in this prism, you should find that I have 24 cubes. Now let's look at some more examples. I'll start by stating that I can call the object that I have drawn here a rectangular prism because the bases are rectangles. I can find the perimeter of one of these bases by adding the lengths of all the sides in blue. Note that the lateral faces are rectangles, and so the lengths of these sides will match the lengths of the sides above them. I can find the area of one of these bases by multiplying 8 inches by 9 inches. Since this gives me 72 square inches, I can say that the area of a base of this prism must be equal to 72 square inches. To find the lateral area of this rectangular prism, I can use the first formula at the top of the screen. As I just said, I can say that the perimeter of one of my bases is equal to 34 inches, and so, to find the lateral area of this prism, I can multiply this by 12 inches. To simplify this, I'll note that 34 times 12 is equal to 408, and inches times inches is equal to square inches. This tells me that the lateral area, or, in other words, the total area of all the vertical faces of this prism is equal to 408 square inches. To find the total surface area of this prism, I just need to add this to the area of the top and the area of the bottom. Or, in other words, I can use the formula that you see here. To simplify this, I'll note that the order of operations says that I must multiply 2 times the 72 square inches first. Adding 408 square inches to 144 square inches is a lot like adding 408x squared to 144x squared. Since 408x squared plus 144x squared is equal to 552x squared, I can say that the total surface area of this rectangular prism must equal 552 square inches. As I said earlier, I can say that one of the bases of this rectangle has an area equal to 72 square inches. So, to find the volume of this prism, I can multiply 72 square inches by 12 inches. To simplify this, note that 72 times 12 is equal to 864, and I can multiply square inches times inches by noting that this means that I want to multiply inches times itself 3 times. To find the total surface area and the volume of the cylinder I have drawn here, I'll start by talking about the circumference and area of the bases. I can say that the circumference of either base is equal to 6 pi meters, and I can say that the area of either base is equal to 9 pi square meters. This means that I can find the lateral area of this cylinder by substituting the numbers into the formula at the top of the screen, like you see here. To multiply 6 pi times 5, I'll note that this is a lot like multiplying 6x times 5. Since 6x times 5 is equal to 30x, I can say that 6 pi times 5 is equal to 30 pi. And, of course, meters times meters is equal to square meters. This means that I can now say that this cylinder has a lateral area of 30 pi square meters. To find the total surface area, I just need to add this to the areas of each of the bases. To simplify this, the order of operations says that I must start by noting that 2 times 9 pi square meters is equal to 18 pi square meters. This tells me that the total surface area of this cylinder is equal to 48 pi square meters. To find the volume of the cylinder, I'll note that, as I said earlier, I can say that the area of either of the bases of this cylinder is equal to 9 pi square meters. This means that I can find the volume of the cylinder by multiplying 9 pi square meters by 5 meters. Since 9 pi times 5 is equal to 45 pi, and since I can multiply square meters times meters by noting that this means that I want to multiply meters times itself 3 times, I can now say that the volume of this cylinder must equal 45 pi cubic meters. To find the lateral area, total surface area, and volume of the prism you see here, I'd like for you to consider the model I have here. When they see this problem, many students try to use the rectangle that measures 3 centimeters by 7 centimeters as the base of the prism. However, the definition of the base of the prism says that all the lateral faces must form 90-degree angles with the base. Since this face does not form a 90-degree angle with the face that is currently on the bottom, I cannot use the face that is currently on the bottom as the base of my prism. So, to work this problem, I'll start by turning the prism like this. Now, because all my lateral faces form 90-degree angles with the triangles, I can say that the bases of this prism will be triangles. To find the perimeter of one of these triangles, I have to use the Pythagorean theorem again. Note that I want to find the length of the side of the triangle that is opposite the 90-degree angle, and so I will leave c as a variable. Also note that I know the lengths of the two sides that form the 90-degree angle, and so I can substitute those measurements for A and B. This tells me that the third side of this triangle must have a length of 5 centimeters. I can now find the perimeter of the base of the prism by adding the lengths of the sides of the triangle you see outlined in blue here together, and so I can say that the perimeter of one of my bases must equal 12 centimeters. To find the area of one of these bases, let's go back to my model. As I talked about earlier in the video, I can use the formula area equals 1/2 times base times height to find the area of a triangle, but if I use this formula, the base and height must form 90-degree angles. Since the two sides that you see here do form 90-degree angles, I can use these two sides for the base and height of my triangle. Note that I did not call this the base and height of my prism because those are two completely different concepts. This tells me that I can say that the area of each of my triangular bases is equal to 6 square centimeters. This means that I can find the lateral area of this prism by performing the calculations you see here. To see why I said that the height of this prism is 7 centimeters, recall that we had to turn the prism so that the bases are the triangles. To find the total surface area of the prism, I can add this to the areas of each of the bases. This tells me that the total surface area of this prism must equal 96 square centimeters. To find the volume of this prism, I'll note that, as I said earlier, each base of this prism is a triangle with an area equal to 6 square centimeters, and the height of the prism is equal to 7 centimeters. Since 6 times 7 is equal to 42, and since square centimeters times centimeters is equal to centimeters times centimeters times centimeters, I can say that the volume of this prism must equal 42 cubic centimeters. For my last example, I'm going to find the total surface area and the volume of the sphere you see drawn here. As the formulas on the screen show, I can find the total surface area of a sphere by multiplying 4 pi times the square of the radius, and I can find the volume of a sphere by multiplying 4/3 pi times the cube of its radius. Since the radius of a sphere is equal to the distance from the center to a point on the outside of the sphere, I can say that the radius of the sphere must be equal to 6 millimeters. That means that I can find the total surface area of this sphere by multiplying 4 pi times the square of 6 millimeters. To simplify this, I'll start by noting that 6 millimeters times 6 millimeters is equal to 36 square millimeters. And now I can simplify this further by noting that 4 pi times 36 is equal to 144 pi. And so I can conclude that the total surface area of this sphere must equal 144 pi square millimeters. To find the volume of the sphere, I can multiply 4/3 pi times the cube of 6 millimeters. To simplify this, I'll start by noting that 6 millimeters multiplied by itself 3 times is equal to 216 cubic millimeters. Since 4/3 pi times 216 is equal to 288 pi, I can conclude that the volume of the sphere must be equal to 288 pi cubic millimeters. If you enjoyed this video, then please subscribe to our YouTube channel and see all of our products available at algebraforhomeschool.com.